everyone, this video is basically notes on how to prove angle pair congruence. So we have some theorems. First is right angle congruence theorem. All right angles are congruent. Now the converse doesn't work. So if you write if all angles are right angles, then they're congruent. But not necessarily all congruent angles are not right angles. So this doesn't work. It only is a conditional statement. So we have to write a proof here. It's about perpendicular lines, and we're going to use deductive reasoning to show that the angles are right angles. So basically, we're given that line segment JK is perpendicular to KL, and ML is also perpendicular to line segment KL. Angle K and L are right angles, and that's definition of perpendicular lines. Therefore, angle K is congruent to angle L, and that's your right angle congruence theorem. All right, we have two more theorems. The congruent supplements theorem. It's basically saying if two angles are supplementary to the same angle or to congruent angles, then they are congruent. So if angle 1 and 2 are supplementary and angle 3 and 2 are supplementary, then angle 1 is congruent to angle 3. For two angles that are complementary to the same angle, or two congruent angles, then they're congruent. So if angle 4 and 5 are complementary, means they add up to 90, and angles 6 and 5 are complementary, then that means angle 4 is congruent to angle 6. All of these are congruent. All right, so we have a proof here. Given that angle 1 and 2 are supplementary and angle 1 and 4 are supplements, we want to prove that angle 2 is 45 degrees and prove, this is given. It's given that measure of angle 2 is 45. Prove that the measure of angle 4 is also 45. So we have to write the given. And they wrote down this part for their given. And so therefore, the angle 2 is congruent to angle 4 because they're supplements. And that is this theorem here, congruent supplements theorem. Therefore, the measure of angle 2 equals the measure of angle 4. So that's definition of congruent angles. And if we have measure angle 2 equals 45, the measure of angle 4 is 45, because all I'm doing is substituting. Since these two equal, I can easily write this as measure of angle 4 equals 45 degrees. All right. It says in example 1, you're given that angle K is congruent to angle angle L. Can you use the right angles congruence theorem to prove that angle K and angle L are right angles? And no, you can't, because the converse of the right angles congruence theorem is not always true. So that's what I said in the first slide, that just because it is congruent doesn't mean they are right angles. Now, suppose angle A and angle B are complements, and angle A and C are complements. Can angle B and C be supplements? No, these two are basically separate. The supplements, remember, that's based off 180 degrees. And the complements is basically the 90 degrees. They add up to 90 degrees. They're separate things. All right. The vertical angle theorem and postulate 12. So if two angles form a linear pair, then they are supplementary. So angle 1 and angle 2 form a linear pair. So they are supplementary, and they add up to 180 degrees. And then we're going to use our vertical angle congruence theorem. That means if you have vertical angles like this, these two angles are congruent, and these two angles would be congruent. All right. So it says given that 4 is a right triangle, and we're going to prove that 2 and 4 angles 2 and 4 are supplementary. So it's given that 4 is a right angle. Therefore, we know that measure of angle 4 is 90 degrees. Definition of a right angle. And then that means the measure of angle 2 is congruent to measure of angle 4. So this must be a right angle. That's your vertical angles congruence theorem. Therefore, the angles equal each other. In fact, they equal 90 degrees. And then using substitution, I know that the measure of angle 4, since these two equal, also equals 90 degrees. Sorry about that. Let's see. Measure of angle 4 also equals 90 degrees. If you add them up, then that would make it 180. So they are supplementary. And we have an example here. Measure of angle 4 is 63. So we know that measure of angle 2 is also 63 degrees. And then using your supplementary angle theorem, you take 180 minus 63, and you're going to get 59 degrees. And then using your vertical angle congruence theorem, this measure of angle 3 would also be 59 degrees. All right. Now, let's see. Which one was I looking at? Let's see, I was looking at the wrong one. So, basically, measure of angle 1 is 117. So, this is 117. And if you subtract from 180 using your supplementary angle theorem, this would be 63 and 63. And if you add them all up, they equal 360. And you can do that one there. I kind of messed up on that one. All right. So let's look at this one here. We want to find the measure of angle AEB. Due to our vertical angle theorem, these are congruent. So I can set them equal each other and solve for x. I'm using my subtraction property of equality and my addition property of equality to solve for x. So you get x equals 22. When I plug 22, I'll just plug it in here. So you have 3 times 22 plus 4. That would equal 70 degrees. So both of these are 70 degrees. You can check it. And then if this is 70 and I have my supplementary angle theorem, then this side would be 110, and this would also be 110. All right. And we actually did this at the beginning of the year, but we're going to use x to find the measure of FKG. So where's FKG? So we want to find this. FKG. this angle here, that measure. So I know there's supplementary angles, so I'm going to add them up as such. So we have 4x minus 1 degrees plus 113 degrees equals 180 degrees. And then they actually did it. We simplify. You going to have 4x plus 112. Subtract from both sides, and you get x is 17. Basically, just subtracted 112 from both sides. All right. And then use the 17 just to plug it back in like we did here. And that's it. Thank you. Have a nice day. Bye-bye.